Hi everybody, my name is Peyton Knight and I'm in Miss Newby's 7th period chemistry class. And recently we've been discussing the imperial formula and how to do them and what they are. So I'm sure some of you are asking, what is an empirical formula? Well, an empirical formula is the simplest positive integer ratio of atoms presented in a compound. So some examples of this would be things like C3O4, O7P1, and I'm sure all of you know H2O, which is water. So now that you guys know what an empirical formula is, we're going to go through the steps on solving one. So the first step would be to change the mass of the elements to moles. Okay, your second step would be to divide by the lowest mole, but number 3 only happens in special cases. This is if the mole ratios aren't whole, then you must multiply by the lowest number. So let's do a few now. Okay, so the first problem that we'll do says to calculate the empirical formula of the compound that contains 4.20 grams of nitrogen and 12.0 grams of oxygen. So to solve this, the first step would be to take your nitrogen. So you take 4.20 grams times 1 mole over the average mass, which you can find this on your periodic table. So you would find nitrogen. So nitrogen's average mass is 14.01 grams. So you want to cross this out, you want to multiply across. So that'll give you 4.20 over 14.01. Which you put that in your calculator, it'll give you 0.299, which rounds up to 0.300. So the next step after this would be to take your oxygen, put 12.0 grams times 1 mole over whatever your oxygen is. So let's go on the periodic table. That is 16.00 grams. Cross multiply. You get 12.0 grams or 16.00. If you put that in your calculator, it should give you 0.75. Okay, so after you've solved these problems, you want to take your answer and you want to put them aside for a second. So now you're going to write your compound out, which would be NO. Okay? So after you have this, you want to take your smallest number here. So your smallest number would be 0.30. So you want to take 0.30 and you want to divide it by 0.75. Okay, so you take your smallest number and you divide it by the first. So 0.30 is divided by 0.300 equals 1. So then you take this down here and then 0.75 divided by 0.300. Put that in your calculator. And that will give you 2.5. Okay, so now once you've had these numbers figured out, you're going to do, for nitrogen, you would do 1 plus 1, which equals 2. So you put in 2. So then you want to do 2.5 for oxygen plus 2.5. And that should give you 5. So your answer for the empirical formula should be N2O5. Okay, so the second problem says when 20.16 grams of magnesium oxide reacts with carbon monoxide forms and 12.16 grams of Mg metal remains. What is the empirical formula of magnesium oxide? Okay, so the first way you'd go about solving this problem is you would take 20.16 G and 12.16. Okay, so then you do 20.16 G is 12.16 G, and that should give you 8.00 GO. So the next step to solving this problem is you would want to take your 12.16 grams times 1 mole over whatever the average mass is of Mg. So you look, that's 24.31 grams. You multiply across and you divide your 12.16 divided by your 24.31. My calculator, that says 0.5002 moles O/mg. Okay, so once you figured out what your mg equals, you don't want to take your 20.16, you want to scratch that out because that's not important anymore, and you want to take your 8.00 grams, and then multiply that over 1 mole, divide, and you want to take, since it's oxygen, you want to take 16.00 grams. Do what you did up here, get that across, divide 8.00 divided by 16.00, that should give you 0.500 moles of oxygen. Okay, so after you found your magnesium and your oxide numbers, you want to once again divide by the smallest number. So your smallest number here is 500. So that divided by 0.500 should give you 1 oxygen. You divide this by 0.500, that should give you 1.004, which just rounds to 1. Okay, so since both of these rounded up to 1 and equaled 1, your compound would stay the same. So it would not change from MgO, which just stands for magnesium oxide. So it would stay exactly the same. Well, guys, I think that wraps it up on what to do for empirical formulas and how to solve them. Thank you for watching.